Here is another interesting problem to understand how to sketch a piecewise function. Question number 6. F of x is equal to x minus 2 whole square when x is less than 3 and is equal to 2 over 3x minus 1 when x is greater than or equal to 3 but less than 6, and it is equal to 4 if x is greater than or equal to 6. Here we have three pieces together, correct? And what should I do first? I should break my plane into three pieces, right? This time I'll break my plane into three pieces with the help of a table itself, right? So let me use this space to make a table. So this is my table where that's my parabola, and then I have a straight line, and then I have a constant function 4. Good. I should have problems like this always. I introduced constant function this time because I realized in first 4 examples I haven't taken any constant function. At times student gets troubled with even constant function. They think it is just a point 4. No, it is not. It is y equals to 4, a horizontal line, okay? Correct. So let me make this table a bit more interesting. We'll make it like this. Good job. Now here, let's write down what these pieces are. First piece is x minus 2 whole square. This is a parabola which is moving 2 units to the right and it opens upwards. Good job. And so we say this is a parabola which will be moving 2 units to the right but look like this. Is it okay? The next one for us is 2 over 3, a fraction, don't get afraid of it, 2 over 3x minus 1, since 3 will get cancelled out. So it's just a relief for you. And here we'll take is a straight line with a slope of 2 over 3 and y-intercept of minus 1. So straight line going upwards. Perfect. And third and final is the most beautiful function which just says 4. It means y equals to 4 and that line is a horizontal line like this, y equals to 4. Is it okay? Right. So let me fill these values for 4 first, right? Greater than or equal to 6. So it starts with filled in, right? And greater than or equal to 6 means at 6 the value is 4, at 7 the value is 4, at 8 the value is 4, and so on. This was good. So you got this, right? Let's sketch it also. We're done with at least 1/3 of the problem. So at 4, at x greater than or equal to 6, we have 4. So 1, 2, 3, 4, 5, 6, we have 1, 2, 3, 4. That's filled in and there it goes. I hope you can see this light color also. Okay, that may help a bit. Let me write 6 here. Okay, sometimes I may even count it wrong. Fine, now let's get into the line business. Line starts with 3. 3 is included. Good part. So it actually starts with filled in but ends with a hole. Remember that part. That is this. Okay. Now when you write 3 here, that means x is 3, then 3 and 3 cancel. Good for us. And we get 2 times 1. 2. 2 minus 1 is 1. So the point is 3, 1. For a line, 2 points are enough. So let's not get into other points straight away. 6, which is a whole, right? So let me write this 6 here. And 6 times 6 divided by 3 is 2. 2 times 2, 4. 4 minus 1, 3. So we get this point, 3. Let me draw this function, okay? So 3, 1. So 1, 2, 3, and we get 1 which is filled in, right? 3, 1. Okay, filled in. And 6, 3, which is a whole. So at 6 we have 1, 2, 3, which is a whole, not filled in, right? So we'll join them together. We see there is a discontinuity here, and this kind of discontinuity is called jump discontinuity, right? By now you are an expert. Let me do the third part now, which is the smiley face, parabola, opening upwards. Now it starts less than 3. So let's start with 3. 3 is not included, so first point is a whole. Okay. Now let's put 2, well, what is less than 3? So let me put 3 here. So if I put 3 here, 3 minus 2 is 1, 1 square is 1, right? So I got this point. Left side means I can put 2 now. 2 minus 2 is 0 and 0 square, and then 1. 1 minus 2 is 1, 1 square is 1, correct? And then 0. 0 gives us 2 minus square is 4. We got these points. Let's try to see if we have some. Okay, so we already have a point of symmetry. That's good. Okay, 2, 0, 3, 1. So at 3, we have 1 that matches. Do you see that? So a whole, but it is continuous here. Do you see that? At 2, we have 0. So at 2, we have 0. So that is 2, 0. Perfect. 1, 1. So at 1, we have 1. So the parabola is turning upwards. At 0, 4. 1, 2, 3, 4. It makes sense. Because our steps are 1, 3, 5, 7, right? So one step, then 1, 2, 3. And next will be 1, 2, 3, 4, 5. That's it. So you can go by steps and then join this, right? Okay. Let's join this part and we'll draw arrow here. Arrow here. That's good. So that's the parabola. Correct? That's a piecewise function. It's a good time to check it also, right? So you can see when x is less than 3, I've made a hole here and this point is 3. Correct? At that time, I have a parabola which is less than 3, yeah, increasing, and this at 0 I have 4. So let me write 4 here. Okay. And this point is 3 and 1. Let's write 1. Good. And this is 6 and 3. And that is 6 and 4. Okay, we'll write 4 here, and this is 3, of course. Correct. So that's our equation. It seems to be perfectly fine. Now help me out. Tell me about this piecewise function, right? Describe it. So when you describe it, what all should you consider? I think these are the points which are most important to consider. Whenever you have a function, first write about its domain. And then think about range. And then intercepts. Both x and y intercepts, okay? And then interval. Interval here is for increase. And decrease. Okay? And then you should think about asymptotes. You can also think about end behavior. Right? Some graphs will have symmetry. And there are many other characteristics like turning points. And so on. Good? So this is what you have to always see when you get a graph. And always most important in piecewise function is type of discontinuity, whether they are continuous or not. So first you have to see continuity. And then classify type of discontinuity. Fine. Now at this stage, I would like you to go and review all my examples 1 to 6 and write there the type of discontinuity, right? Here, do you see a discontinuity? Yes, it is at 6. And this type of discontinuity is jump discontinuity, correct? In some functions, you can have infinite discontinuity, like 1 over x, right? Where you have a vertical asymptote. At that case, you may have infinite discontinuity. My examples so far may not have infinite discontinuity. I'd like to add some of those in coming sessions, okay? But this is a good time for you to go back and look into these examples 1 to 6 and write for all of them domain, range, intercepts, intervals of increasing and decreasing, asymptotes, end behavior, symmetry, turning points, okay, and continuity, correct? Now this part of continuity is probably the most important part of this exercise. One of the questions which is always included over this sketching of graph is to algebraically see or check whether the function is continuous or not at the places where it is piecing together or splitting apart, okay? So look into that. Algebraically, how will you prove that this is continuous here at 3? What you can do is plug in 3 here. When you do that, at 3 you get a point 3 and 1, and 2 here also. At 3 you again get 3 and 1. Do you see same points? So once you see at 3 both are same thing, that means this was a hole, right? It got plugged in and therefore the function became continuous. Then you have to analyze for the next piece whether they are getting together or not. At 6, so at 6 you check the values, right? You say at 6 my value is 3 for one function and 4 for the other. Since they are different and like one over the other, like jumps to the other value. Here we have a jump discontinuity. Function is discontinuous at x equals to 6. That summarizes us and brings us to the end of our session of understanding how to sketch piecewise function. I hope you find this exercise extremely important and useful. Write your comments and share with your friends. Thank you.